So welcome to the first lesson of IB, and this is a compilation of two previous lessons that you may have gotten in middle school, but I'm going to go through this with you anyway. But we're going to start off with something simple called rounding. Okay, so you have been rounding for a very long time. So if I say round to 2 decimal places, so what we're going to do for that is we're going to go 2 decimal places. We're always talking about to the right, so we're rounding to that 7. And so we're going to go ahead and look at that 8. So for this number right here, the rule is 5 or above, give it a shove, right? So we're going to move this number up if it's 5 or above. 4 or less, if the 8 is 4 or less, we're going to let the 7 rest, okay? So if we have 5.6, that's going to stay because that's to the left. Now we're talking about the 7, okay, because we're rounding to 2 decimal places. So we look at the number to the right, which is the 8, and we notice that that is 5 or above. So that means that the 7 is going to go up to an 8. Everything to the right is going to drop. Everything to the left is going to stay the same. Okay, so 5.68 is 5.6789 rounded to 2 decimal places. All right, so three significant figures. Significant is how precise a number is. And for IB, you always want to round to 3 significant figures unless you're told otherwise. Okay, so we're going to go through a couple of problems just to make sure that we're good. Zeros to the left are not significant. Zeros to the right are significant. And we're going to say mostly, okay? And make a non-zero sandwich to see how precise the number is. So we'll talk about what that means in a second. All right. So for the first one, pretty straightforward, right? We have non-zero, 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 zero. Zeros to the right are significant. So we have, if we look at this, we have 4 significant figures here. Okay. So for number one, 4 significant figures. Looking at 0.02, it says zeros to the left are not significant, right? So these are not significant. So the only significant number that we have is we have 1 significant figure, and that is the 2, okay? Because it's a non-zero number. Now this one, so 7, right, is a non-zero number, and zeros to the right are significant, right? So this would be 3 significant figures if we're talking about how precise something is. But if we look at how many non-zero numbers there are, this is only one non-zero number, right? So this one is called an ambiguous case. So depending on if we're just taking the numbers and just like rounding them, then it's 1 significant figure. But if we want to be precise and we're counting from numbers 1 all the way up through 700, then that's going to be 3 significant figures. So this one is, like I said, a little bit less precise or less clear. For the last one right here, this is what we talk about with a non-zero sandwich, right? So we have 8 to start, 5 to end, and we have a 0 in the middle. So we count that 0 as significant. So this is 1, 2, 3, 4, 5. There are 5 significant figures here. And if you take a look at this number, it is 5 significant figures is the total for this. All right, so the next topic that we're going to do is something called scientific notation. So scientific notation is a non-zero number. This number has to be between 1 and 10. Cannot equal 10, but a digit. That's not 0. And then there has to be a decimal place after, and then every other number times 10 to some exponent. Okay, so it's best to go through this with a couple of examples. So if I look over here, right, the first number that I have from left to right, we always start from left to right. The first number that we have from left to right is a 3. That is not a 0. So we're going to write 3 point, and then we're going to write all the other numbers to the right that are not zeros at the end. We're going to put the 0 here. So 3.52804. So since this 0 is sandwiched between the 8 and the 4, we're going to count that. That is significant, and we're going to put times 10 to the. And so now, if this was money, right, the decimal would be at the end, right? That's like this much dollars. So if I want to get the decimal to be between the 3 and the 5, we want to count how many times we're going to move this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to move it 10 places to the left, so that exponent is going to be positive. All right. We're going to do another one. This question number 2 right here. So from left to right, the first number that we have that is not a 0 is this 2. So I'm going to write 2 point, all the other numbers to the right, 187, and then we're going to do times 10 to the, so now this one already has a decimal, right? It's right here. To get it to move between the 2 and the 1, which is where we put it here, we go 1, 2, 3, 4. So we're going to go 4 places to the right. So this is going to become -4. Okay. Numbers that are less than 1 are going to have a negative exponent. Numbers that are greater than 1 are going to have a positive exponent. So a couple of things. Why is scientific notation helpful? So we can go ahead and say that it's helpful because we can take very large numbers or very small numbers and put them in a compact way that is normal, okay, that people see it as. Our calculator might do this as well, right? If you get a really, really large number, it might say something E. So E in the calculator, the capital E, just means times 10 to some power, okay? And so we could also know how precise the stated value is. So these are some numbers that might come up. Speed of light, you probably have heard about this in science or maybe even math. So the speed of light is a very specific number, and this number is 3 times 10 to the 8th, and this is meters per second. Okay, meters per second is what this number is. Avogadro's number comes into play like with atoms, and this is something that you might see in science, but Avogadro's number is Na is equal to 6.02 times 10 to the 23rd, so this is a very large number, and this is for atoms per molecule, atoms per molecule. And then the last number that you might see in scientific notation is actually a very, very small number, because this is times 10 to the negative, but we'll talk about that. So this is 6.67 times 10 to the negative 11. And so this number is a very, very small number because our exponent is less than 1, right? So and our unit is going to be G per gram, okay? And just so you know, the pro tip is remember to round to 3 significant figures if not specified, okay? If not, first for IB, everything is 3 significant figures if it's not specified otherwise. And that is our pro tip. All right. So what I'm going to encourage you to do is to go ahead and read through the upper and lower bounds. Basically, what that's saying is what numbers can round to a specific number. So for example, we'll go ahead and just do one, right? So if I say, what numbers round to be 14.3? So what numbers round to be 14.3? Think of 14.3 on a number line, right? And numbers that round to it, all you do is take this number right here. We're going to subtract 1 from it, so that's going to be 14.2. And then we're going to see what number is right half of that, right? So if I look half of between 14.2 and 14.3, that is 14.5. So 14.5, what happens with that, right? If I said rounded to the nearest 1 decimal place, this is going to be 14.3. So 14.5 is going to round to 14.3. And what is the highest or the upper bound? So what you do with this is you're going to go ahead and you're going to figure out what number is the highest bound. So you're basically just going to add a 5 here. So this is 14.35, and it's not going to be including 14.35. So this is less than 14.35, okay? So the shortcut, right? Subtract 1, put a half, like find half of that, and then take the number itself and put a 5 at the end of it. So depending on what it's asking you to round to, there is another example here for the lower and the upper bound. So 9.61, the degree of accuracy here is 2 decimal places, right? So here's 2 decimal places, and you're going to go ahead and do the same thing, right? Take our width, which is 9.61. You're going to take this number right here, and you're going to subtract 1 from it on this side. So this is 9.60. Add a 5 to it, right? So 9.605 is less than or equal to our W, and our greatest number is, you're just going to put a 5 at the end of this, 9.615. And so that is what we have as our lower and upper bound. So this is our lower bound, and this is our upper bound. Okay? Definitely do a couple of problems like this. Here is some examples. So there are some independent skill practice questions. So I'm definitely going to ask you to go ahead and do these questions as well, numbers 1 through 4, and to check your work, okay? I am definitely going to encourage you to pause the video, do the questions yourself. I did see that some of you were struggling with 4A. If you're struggling, watch the rest of this. If you're not, just continue, do this yourself. So we are going to 3 significant figures, right? So 1, 2, 3, okay? So this number is what you subtract 1 from, right? So 3, 4, 5 minus 1 is going to be 3, 4, 4. The number after that is going to become a 5. And since we are going to, this has 1, 2, 3, 4, 5 digits, we have to add a 0 here. So it's going to be 34,450 is going to be our lower bound. So this is X, okay? And then our upper bound is, we're just going to go ahead and take this number. So the 345 is going to stay, and then we're going to add a 5 after it. Again, since we have 5 numbers here, we want to make sure that we add a 0 here, so that is going to be our upper bound, okay? 34,550 is going to be our upper bound, so that is the range of possible values of X. All right, I'm going to do one more. So this one right here is should I do B or C? Let's just go ahead and do B. So we have another number line right here. So I'll go ahead and draw this, and the number that we have in the middle is 0.0301. And so since this is 3 significant figures, 1, 2, 3, right? This number right here. So our lower bound is going to be, we're going to subtract 1 from this number right here. I just caught myself, right? So we're not subtracting 1 from the 0. We are going to, let me take that out, put the 0 back. 3 significant figures, 1, 2, 3, right? We're going to subtract 1 from the 1, which makes a lot more sense, right? Because 1 minus 0 is negative. We don't want that. So we're going to subtract 1 from this number right here, which is going to be 0.0300, and then we're going to put a 5 after that. So that is our lower bound. So 0.03005 less than or equal to, the variable that we have to use is y, less than, and then you're going to put the same number that we have right here. So 0.0301 and add a 5 at the end of that. Okay, so this is our range for our y's. This is our range for our x's. So go ahead and do C and D and check your work. Great job. Tried to keep this video less than 15 minutes. It worked. Please try practice, and then see how successful you are with this lesson. All right, good job. This is, oh, one more thing. This is going to be an all year thing, significant figures, okay? And scientific notation and rounding.